All right, so I took a bit of a break, ate a bit of an apple, I got some new markers. I think I'm ready to go on to example number 2. All right, we're going to do the exact same thing, but what happens if the formula isn't as nice as in example 1? What happens if the equation has a few extra bumps to it? All right, let's solve it. Example 2, solve using the quadratic formula. I want us to go through 2 different examples, A and 2. Ian, I hope you get a good laugh out of that one. A is going to be 2x plus 1 times x minus 1 equals 5x. B, 1/2 x, ooh, the dreaded fractions. 1/2 x squared minus 5/4x equals 3. All right, so what we want to do is we want to get this into, well, for A anyways, we want to get this into a format that is like our, oh, how far can I go here? Very good. That is like our A x squared plus bx plus c equals 0 kind of thing, okay? Because we need to match up the a's and the b's and the c's. So in A, we need to FOIL it out first so that it looks like this. 2x plus 1, x minus 1 equals 5x. So we're going to multiply 2x by x minus 1, so we can do that first. So 2x squared minus 2x, now we're going to go from the second one, plus x minus 1 equals 5x. Let's collect like terms. 2x squared, negative 2x plus x is just negative x, minus 1 equals 5x. What we want to do is we want to set this, though, equal to 0. So we're going to take the the 5 to the other side. So subtract 5 from both sides. 2x squared minus 6x minus 1 equals 0. At this point, we can figure out that our A is 2. A equals 2. Our B is negative 6. And, ooh, do I have another color? No, I can just circle it. And our C is negative 1. So let's plunk that into the quadratic formula. X equals negative 6 plus or minus the square root of negative 6 squared minus 4 times A, which is 2, times C, which is negative 1, all over 2A, 2 times 2. X equals positive 6 plus or minus the square root of 36. Minus 4 times 2 is negative 8 times 1, though, is positive 8. Plus 8 over 4. X equals 6 plus or minus the square root of 44 over 4. And now at this point it's just radical simplification. 4 times 11 is 44. I can pull out a 2 because the square root of 4 is 2, so it looks kind of like this. X equals 6 plus or minus 2 root 11 over 4. I can take out a factor of 2 out of each of my terms here. 2 goes into itself once, 2 goes into 4 twice, 2 goes into 6 3 times. So my x is actually 3 plus or minus root 11 over 2. right, let's move on to B. This one's a little tricky. When we don't like dealing with fractions, what do? We multiply by the lowest common denominator. So if I multiply through by a 2, I'm still going to have this as a fraction. However, if I multiply by a 4, guess what? We can get rid of some of those fractions, and then we don't have to deal with them. Okay, so if I say 1/2 x squared minus 5 over 4x equals 3, I can just multiply all three terms by 4 to get the denominators, well, to get rid of the denominators, essentially. 4 goes into 2, 2 goes into 4 2 times, so we say 2x squared minus 5x equals 12. Now to get it into this format, remember, we need to set it equal to 0. So I need to subtract 12 from both sides. 2x squared minus 5x minus 12 equals 0. I get a little bit of a, I don't know, slap on the wrist maybe for not lining up my, my equal signs. Alright, so at this point we know that A equals 2, B equals -5, and C equals -12. I'm going to I'm going to put it into the quadratic formula. So x equals -b, so -5, plus or minus the square root of -5 squared minus 4 times A times C. All over 2A, 2 times 2. So let's simplify a little bit. We have, x equals 5 plus or minus the square root of 25. 2 times 4 is 8. 8 times 12 is 96. So plus 96 all over 4. 25 plus 96, that's kind of like, oh, but guys, guess what? It's a perfect square. It's 121. So we have x equaling 5 plus or minus the square root of 121 all over 2. Sorry, not 2. I'm sure somebody would have gotten a lollipop over that one, but it's over 4. What we can say here, guys, is that x equals 5 plus or minus 11 over 4. At this point, since we don't have any like crazy square roots, we can actually solve it. So we can actually say something like x equals 5 plus 11 over 4, which, guys, 5 plus 11 is just 16, over 4 is 4. So yeah, 16 over 4 is 4. So we can just say that x equals 4, or x equals 5 minus 11 over 4. That is -6 over 4, okay, which is just -3 over 2. So x equals +4. Oh, can you see that? No, you can't even see that. Sorry, guys. I'm just going to let it be for this time. But I'm sure that you can put in 5 minus 11 over 4 and simplify from there. It is -3 over 2. So I've just done 2 examples like that. So you can look in the book for more examples for worked out solutions. Or you can come to class tomorrow with questions. There's only one more video and it's going to be much shorter, I promise.